Hi guys, for today's video we're going to be dissecting this HOMVANA 101 air humidifier. This thing has a capacity of about 3.6 liters, and as you can see from the current aesthetic design, it actually doesn't look too bad. Now, for the first part we have the top cover assembly. So in this top cover assembly there are two parts where you can just use your hands and pull them out. So you have the navigating disc up here, and then you have the top cover lid right here. These are meant to be easily removed, as for an air humidifier, you need to be able to easily pour water into it. So this design is actually pretty good for what it's made. And it's actually pretty sturdy. You can hear the knocking that the material isn't too bad. So we can assume that it's made out of common plastics such as ABS. For the next part, we have this plastic body. Now, plastic body looks like it's going to be made from the same material or similar, and there are two main components. You have this gasket, and you also have this valve. Now, these are not removable based on how this thing was most likely welded or heat treated to stay in place when it was assembled at the factory. But you can tell by its design that it's a very simple locking mechanism where, based on the pressure of the water, this will either open or close. And now finally we have the base module. Now this is where all the electronics components are installed, and you can see from the back that there are three adhesive units that are for anti-slip for the base module, as well as the power dock. Now, how do we disassemble this? Well, the first thing you want is to have an ear pick, ideally, so that you can scrape off these anti-slip pads from the unit like this. You pry it open a bit, and then you tear it off, and then you will see that there are secured screws inside. So what we want to do is remove all of these so that we can begin screwing. Now we take a Phillips head and start unscrewing the base. Now give it a good knock, and they should come out. If not, just keep unscrewing until you can get these both out. Now you see you have three of these screws that come out. And from that, you can start to pry open, and you will begin to see the separation of the components. Now, I did do a slight dissection earlier to understand a bit of the mechanism and see what it looks like internally, but as you can see, you have for the base base cover, you have these three supporting structures that help align with the screws for when you're combining it with the housing cover. And you can see here on the side you have this essential oil pad and a tray. This is made to absorb the oil from the air humidifier if you want to add essential oils to make your product smell better when it's humidifying. And this and you can tell by the mechanism used, it's a push pin. So when you push it once, it locks, and when you push it out again, the tab releases and you can pull out the tray. And because of this design, it's very simple, and you can replace these oil pads as a consumable when these become full and you need a new one to start using for the next set of oils. Now, for the next part, what we want to look at is the internal walls. As you can see, these internal walls, while they are injection molded into, I do find some issues with it because they don't have these the the rib cages or the rib linings that structurally make this more safe. These internal walls are pretty thin, and if there is high impact, they're more likely to break off. So it's not I would say the best design, but with this design, it does actually reduce some costs as there's not as much material needed to create it. One thing that I will note about the design is these support structures. So you can see that there's an internal radius and external radius that it looks like it's a sheath for something. And once we are done with this bottom cover, we can take a look at the top cover. Ignoring the PCB for now, you can see that for these support structures for this, they do add rib cages, which is a lot better. And for this, this support structure's external radius is actually meant to align with this to actually make it easier to assemble as almost like a sleeve. And with that alignment, it does make the assembly process a lot easier. And now let's get into the main controls. So we have this DC motor fan that is from a off-the-shelf market, where you can see that it's made out of some sort of plastic. And the main issue with these types of things is since they're off the shelf, you have to customize your CAD to be matching for this. And what we can see with the internal lining is that they have created this very thin wall and rib design so that it can easily match with the air pressure inside, as well as getting the tight fit around the product. So these internal ribs, as you can see, are meant to help hold the product in place as a way of support, rather than using maybe padding or like a lock-in type clips. Next we have is the PCB. So this is the PCBA assembly that they have, and they have this display module from this that reflects to this front end, as well as they're using the spring coils as a way of sensors, as a form of sensors, as opposed to normal buttons to interact with the user. One thing to note about this design is I don't agree with this form of design for a button, because while this is great to have it very tight fit to the system, and having this rib slash you can see here in this rib that there is almost like a slot for the sides of the PCB board based on the thickness. It does create a secure lock or a very tight lock around it, and having these spring holes or cylinders align with these circular ID units makes for a great assembly process. It's hard to disassemble because these are kind of as a tight fit, and once you pull them out, as you can see, it's very hard to fit back in without an actual fixture. So because the springs deform and they deflect as you put it back in, along with this matching rib lock. And then you have this power drive, which we will use another Phillips, which we will use the same Phillips to unscrew to look at the final components. which this would be your magnetic, your ultrasonic disc. So as you can see, this mechanism has both this seal, which is made out of a silicon rubber, and this is attached to a metal plate with its own PCB that is screwed on at both ends and connected to a power attachment. And then at the top, at the back, you have this shield can, which is meant to protect the assembly of the disc to the PCB with this metal guard. Now, this assembly is most likely from outsourced by a vendor to supply you based on the dimensions that you require, or it's based on their off-the-shelf and with their own specific shield cover design, where they just send you the full assembly. And you can see here on the base ring, you have the magnetic connections between the PCB and the actual system. This is supposed to help pressurize the water and create the mist. And those are the main parts of the assembly. You can see from that for this ring design, that it's actually a good fit, where you have these threaded screws locations to help indicate where the screws need to be placed in relation to this metal frame. Overall, it's not a bad design. One thing to note is that the ribs in the housing cover is a lot better designed than the base cover, which I am actually curious why they only added ribs to one of their housings as opposed to another one for their other plastic modules. If I were to redesign this, I'd probably increase the ribbing on these and potentially reduce the overall size of the supports so that it doesn't need to use as much material first. And then the second is I would redesign this button structure so that it doesn't rely on this type of mechanism for access to the people, so that it becomes an easier assembly. Overall, I give this disassembly and this product design at best an 8 out of 10, due to the fact that most of the parts you can easily reassemble with the screws that's provided and the structure, but there are rooms for improvement based on the structural design for the molds as well as the PCB design for the functions. Thank you.